Welcome to our comprehensive guide on migrating a monolithic Java project to AWS using a microservices architecture. It's a journey we're about to embark on together, and I'm thrilled you're here. Now, as you know, monolithic architectures have served us well for years, but as applications grow in complexity and scale, their limitations become increasingly apparent. That's where microservices come in, offering a more agile and scalable approach to software development. This process involves careful planning, design, and execution to ensure resilience and minimize dependencies, ultimately leading to a more robust and maintainable application. We'll delve into each step, providing practical insights and best practices to help you navigate this transition successfully. Over the next few chapters, we'll transform your monolithic Java application into a thriving ecosystem of microservices on AWS. Get ready to unlock the true potential of your applications with the power of microservices. Before we dive into the technical details, it's crucial to take a step back and analyze our existing monolithic application. We need to identify what parts would benefit most from a microservices architecture. Once we understand our monolith, we can define microservices boundaries. Domain-driven design, DDD principles, help identify bounded contexts. Data migration is another critical aspect to consider. Monolithic applications often rely on relational databases, but microservices benefit from NoSQL. Careful planning is crucial for a successful migration. By understanding our starting point and defining our target architecture, we lay a solid foundation. So let's roll up our sleeves and start building the blueprint for our microservices transformation. It's time to break down our monolithic application into microservices. Start with the most loosely coupled components. Establish robust communication between microservices. Use an API gateway for client requests. Effective service communication is key. Explore RESTful APIs and messaging queues. Adhere to loose coupling and high cohesion. Each microservice should have minimal dependencies. Refactoring is an iterative process. Identify logical components to extract. We'll have microservices ready for AWS deployment. Now, let's talk about data. Monolithic applications often rely on a single, centralized database, which can become a bottleneck in a microservices architecture. We'll explore the world of NoSQL databases and how they align perfectly with the principles of microservices. Choosing the right NoSQL database for each microservice is critical. We'll delve into different NoSQL database types such as document databases, key value stores, and graph databases, highlighting their strengths and ideal use cases. Next, we'll redesign our data models to embrace the schema flexibility of NoSQL databases. We'll break down our monolithic data structures into smaller, self-contained units, each managed by its respective microservice. Migrating data from our existing relational database to our new NoSQL databases requires careful planning and execution. We'll discuss different data migration strategies, including batch processing and real-time replication, ensuring data integrity throughout the transition. Remember, this chapter is all about embracing the flexibility and scalability of NoSQL databases to empower our microservices architecture. It's time to deploy our microservices to the cloud, and what better platform than Amazon Web Services? AWS provides a comprehensive suite of services designed specifically for microservices architectures. Get ready to experience the true power of the cloud. First, we'll package our microservices as containers using Docker, ensuring portability and consistency across different environments. Containers provide a lightweight and isolated environment for our applications to run seamlessly on AWS. Next, we'll explore different orchestration options such as Amazon Elastic Container Service and Amazon Elastic Kubernetes Service. These services automate the deployment, scaling, and management of our containerized microservices. For those looking for a serverless approach, we'll dive into AWS Lambda. With Lambda, we can run our microservices without provisioning or managing servers, paying only for the compute time we use. By the end of this chapter, our microservices will be deployed on AWS, ready to handle the demands of our users. In a distributed system like ours, failures are inevitable. We'll equip our microservices with resilience and fault tolerance mechanisms, implementing circuit breakers to prevent cascading failures, retry mechanisms for transient errors, and timeouts to prevent hanging requests. Monitoring and alerts will detect anomalies early, allowing proactive measures to maintain system health. By the end, our architecture will be fortified, capable of weathering the storm. Security is paramount, especially in a distributed microservices environment. This chapter will guide you through implementing robust security measures to protect our valuable data and applications. We'll leverage AWS identity and access management to control access to our AWS resources, ensuring that only authorized entities can interact with our microservices. Encryption will be our shield, protecting sensitive data both in transit and at rest. We'll establish secure network communication between our microservices using virtual private clouds and network security groups. These measures will create a secure and isolated environment for our applications to operate. Throughout this chapter, we'll adhere to security best practices and industry standards, ensuring that our microservices architecture remains compliant with relevant regulations. By the end of this chapter, our microservices architecture will be fortified with robust security measures, safeguarding our data and applications from potential threats. Testing is crucial in software development, and microservices are no exception. We'll establish a testing strategy to ensure quality and reliability. Starting with unit testing, we'll focus on individual microservices. Then, we'll verify interactions with integration testing. Techniques like contract and end-to-end testing will be explored. Load testing will assess performance and scalability. Simulating high user loads helps identify bottlenecks. Chaos engineering tests system resilience. Deliberate disruptions reveal improvement areas. By the end, we'll have a robust testing strategy for our microservices. In the world of microservices, agility is key. This chapter will guide you through setting up a robust continuous integration and continuous deployment pipeline, automating the process of building, testing, and deploying our microservices. We'll leverage popular CI/CD tools such as Jenkins, AWS Code Pipeline, and AWS Code Build to create an automated workflow. Our pipeline will trigger automated builds and tests upon every code commit, ensuring that our microservices are always in a deployable state. We'll explore different deployment strategies such as blue-green deployments and canary releases to minimize downtime and reduce the risk of deployments. These strategies allow us to release new versions of our microservices gradually, ensuring a smooth transition for our users. By the end of this chapter, we'll have a fully automated CI/CD pipeline in place, enabling us to deliver new features and updates to our users rapidly and reliably. In a distributed microservices architecture, understanding the health and performance of our system can be challenging. This chapter will guide you through implementing comprehensive monitoring and observability solutions, providing us with deep insights into our microservices ecosystem. We'll set up centralized logging to aggregate logs from all our microservices, making it easier to troubleshoot issues and identify trends. Distributed tracing will allow us to follow requests as they flow through our system, providing a holistic view of the entire request lifecycle. Metrics and dashboards will play a crucial role in monitoring the health and performance of our microservices. We'll define key metrics, such as request latency, error rates, and resource utilization, and create informative dashboards to visualize these metrics. By the end of this chapter, we'll have a comprehensive monitoring and observability system in place, giving us the visibility we need to ensure the health, performance, and reliability of our microservices architecture. Congratulations! We've successfully migrated our monolithic Java project to AWS using a microservices architecture. But our journey doesn't end here. Microservices are all about continuous improvement and iteration. We'll establish a feedback loop, gathering data from our monitoring systems, user feedback, and business metrics. This valuable information will guide our future development efforts, allowing us to identify areas for optimization and enhancement. As our application evolves and business requirements change, we'll continue to refactor and optimize our microservices. We might identify new functionalities that warrant the creation of new services or discover opportunities to further decouple existing ones. Remember, migrating to a microservices architecture is not a one-time event. It's a journey of continuous learning, adaptation, and improvement. By embracing this iterative approach, we can ensure that our microservices architecture remains flexible, scalable, and aligned with our business goals. Thank you for joining me on this incredible journey. Thank you for watching our guide on migrating a monolithic Java project to AWS with a microservices architecture. We've covered a lot of ground from analyzing our monolithic application to deploying and managing a distributed system of microservices. Remember, this is an iterative process and continuous optimization is key to success. As you gain more experience with microservices, you'll discover new ways to improve the scalability, resilience, and maintainability of your applications. Don't forget to like, share, and subscribe for more informative content. We're committed to providing you with the knowledge and resources you need to thrive in the ever-evolving world of software development.